My name is Dhruv Bantval. I'm in 8th grade, and my project is a smart glove with American Sign Language to speech conversion to assist the hearing impaired. In this engineering project, a prototype of a device used to convert American Sign Language to speech was developed to assist the hearing impaired. The device takes American Sign Language letters, words, and numbers as inputs and decodes them with a 95 to 100% accuracy rate. Globally, there are millions of people who suffer from some form of hearing impairment, the most common ones being sensorineural hearing loss, conductive hearing loss, and mixed hearing loss. In order to communicate with society, researchers studied multiple different approaches, the main two being image processing and data gloves. The main one I'm going to be talking about today is data gloves. The first two examples here are already built data gloves, but as you can see, both of these have less than a 95% accuracy rate. This third example is currently the only purchasable data glove with a cost of over $2,500. Some of my design criteria were affordability, accuracy, compatibility, and usage. The glove should be cheap and affordable. It should speak letters through a speaker accurately. The glove should be able to accurately detect all signs made and not state the wrong letter, number, or word when trying to make a sign. The glove should be compatible for anyone who can fit the glove. If one cannot fully do the ASL sign, the glove should still be able to recognize what letter, number, or word they are trying to sign. And the glove should improve the convenience of conversing with someone who does not know sign language. The device should be non-complex and easy to adapt to. For my assembly procedure, there are two main components, the hardware assembly and the programming. For the wiring part of the assembly, I use one flex sensor for each finger. I then glued the sensors to the glove, then soldered the wires to the flex sensor for stability. I used a breadboard to make the connections from the Arduino board to the flex sensor. For the programming part of the assembly procedure, it was more complex. I created functions to read and store positions of the user's hands making different signs. After this, the program checks the current output of the flex sensors with the stored values. It then decodes the correct letter, number, or word made. As you can see here, this is some of my code I used, including the configuration part, the calling of the configuration process, and the decoding. Some methods I used to test the accuracy of the glove is I first ran the configuration code, during which I made each hand sign once. I let the program store all of the variables. Then I ran the decoding code and made each hand sign 20 times in a randomized order. Figure 4 shows the overlap of the flex sensors. Even though the flex sensors overlapped on certain values, mainly the sensor 2, when the reading is taken all together, the letters are decoded uniquely. The sensor 2 is the pointer finger, and it's the most commonly bent finger in the American Sign Language, hence why almost all of the letters drop to around 675. Overall, the glove is able to detect 10 letters, 3 numbers, and 3 words the user is trying to make with a 95 to 100% accuracy rate. The American Sign Language is converted to text and speech. In the experiment, less than 5% of the time, the glove could not detect the sign to a letter or word due to a user error. Some unexpected problems were when creating a program to decode the signs. Many problems occurred because all of the flex sensors had different values. I solved this problem by creating code to store the values and then subtract them instead of having set values, letting the glove be compatible with everyone. Another problem I had was a hardware issue in which the flex sensors did not connect to the wires. Therefore, I had to solder them into place. All in all, the glove was able to decode with a 95 to 100% accuracy rate, fulfilling the accuracy requirement. The glove was affordable, coming at $85, fulfilling the affordability criteria. And when testing the glove, I sometimes was not able to make the full sign, although the glove was still able to recognize which sign I was trying to make, fulfilling the compatibility requirement. And the glove is easy to use and understand as the program runs It prints what needs to be done in detail for the user, such as lay your hand flat or make a Y, fulfilling the use criteria. In conclusion, this glove satisfies all of the design criteria and is an effective conversing tool for the hearing impaired. The glove is accurate, easy to use, and compatible with most people. The glove can help converse easier with people who do not know American Sign Language, and with further development, this glove could be an effective tool used to converse with others in real time. Some next steps in future research would be compacting the glove for easier use and less chance of it breaking, increasing the speed of the decoder for better convenience, increasing the versatility of the glove to be able to decode all 26 letters of the alphabet, and introducing artificial intelligence to help with compatibility in conversing.